Welcome to episode 22 of Ask the Grounding Experts, where our experts from E&S Grounding Solutions answer your engineering questions about the world of grounding and earthing. Today, E&S President David Stockin goes over the importance of addressing grounding issues at the beginning of a project, because if you don't, your costs can run through the roof, and that's not even counting the additional cost for aspirin that you'll need for the big headache that you and your customer will have. Break it down for us, David.
Yeah, so welcome. This episode today we're going to be talking about why it is important to address grounding systems during the design phase or very early in your project. And man, is this an important topic. I had a client literally recently just called and said, we could have spent $10,000 during design to save $1 million later. And I can't tell you how many times we get a phone call from an electrician who's out on the site, says, we have a spec to make sure that the ground system is 5 ohms. And the electrician has no authority to change grounding systems or to design it, has no power other than to conduct a test. And whatever the result is, it comes out, and then it's back to the design board. And they've got to get the engineers involved, they've got to get change orders, change things up, and sometimes a little bit of forethought could have fixed the problem, especially when we look at deep earth footings. Here they are, they spent millions of dollars drilling deep footings into the ground, and a simple copper wire added to it could have resolved their entire spec grounding problems and helped provide a safer, more efficient footing that would last longer and not be as susceptible to damage over time. All for basically free if it had been looked at in the beginning. So before we get too deep involved, let's take a little bit of a step back on this and just consider for a moment all the things that are involved in grounding. So think of your home for a moment. When we look at the circuits, you've got a black wire, a white wire, and a green wire. 2 of those wires are grounded. Right? Both the green wire and the white wire are grounded. Remember, grounding starts at the exo of the transformer. The International Space Station is full of grounding, right? 747s, your car. Grounding doesn't start at the earth, it starts at the transformer of the circuit. And it goes from the top of a lightning aerial all the way down to the tip of a ground rod, from the exo of the transformer out to the final branch circuit, and every single metal touchable object in between. So when you look at your house, you have a hot wire, that's not grounded. The neutral wire is, the ground wire is, your data communication lines are, your steel rebar is, your cold water pipe, your gas lines, if you have a lightning protection system, that's bonded, your steel structure is bonded, your cable television system is bonded, any data lines or alarms or fire alarm systems you may have, those are bonded. You have more grounding in your home than you do hot wires by far. And this is true virtually everywhere. When you get into industrial systems, it even becomes more. We often have equipotential grounding systems in addition to it, or isolated ground systems, or instrumentation ground systems. Oftentimes there's far more of all the copper installed, far more of it has to do with grounding than it does with anything dealing with electrical power systems, and yet we tend to completely overlook it. How do you bond in a data communication system into a high voltage environment? Where's the fault current path that occurs when the high side of the utility transformer faults? Is it through your ground system or somewhere else? And can that cause high voltage issues and increase your liability, especially if you're an employer and you're subject to 29 CFR 1910.269 Appendix C, where you are required by law, if you have more than 1,000 volts, to make sure that your employees are not going to suffer from an electrocution due to a fault at that transformer, whether you own it or not. All these things need to be looked at. And when we get into designing, oftentimes I get that phone call from from someone, and they say, "Oh, we've already started pouring concrete, and we did some testing, and we're not meeting the specs." It's like, you're already pouring concrete? Half of what we can do for you in grounding involves the concrete. Today, we have a huge theft problem of copper. So if you're in the telecommunication industry and you're dealing with cell sites, you know this very well. People jump the fence, they steal the copper bars, they just go through with a pair of bolt cutters and they just steal everything copper they can get. They run it down to the scrapyard, they get a couple $100, but they can cause tens of thousands of dollars, sometimes over $100,000 worth of damage can be occurred. Especially if they start snipping those coax lines, it can start approaching some really big numbers really quickly. I've heard of stories of almost $250,000 worth of damage done to some of these cell sites when it gets down to replacing these gas-filled coax lines. It can be incredibly expensive. So embedding the copper into the concrete foundations before you ever bring equipment in, while you're still pouring pads, can be one of the best cost-saving ways that you can deal with your grounding system. Not only does it take care of electromagnetic interference issues with the steel rebar in there, but it saves you labor later because you don't have to run it in conduit. You just put it in the concrete and hand tie it down to the piece of steel rebar. You place a pad and a flush-mounted pad on your concrete pad, ready for the installation of your transformer or equipment shelter or panels, whatever it may be, and you have those pre-planned. You can actually save a lot of time and money in labor and have simple little jumper wires that can be easily replaced. You never have to rebust up concrete. You don't have big, massive grounding systems stretched all over the place, and it can make your site not only look a lot cleaner, the less theft problems, less trip hazards, and it saves you money in the long run. But it needs to be thought about in advance and designed. Right? We need to take a minute to consider those things while we're still putting out the blueprints and in AutoCAD, and make sure that stuff gets designed in there properly. So many times we start reviewing designs and complete systems were just missed. The lightning protection system completely forgotten about in a high lightning risk area, and it has to come back later and be re-added. Or the neutral ground bonds are in a campus environment and they've installed neutral ground bonds and are generating objectionable currents in violation of 250.6. Simple things that could have been handled during the design phase to remove or to improve the fault current path so that we aren't generating GPR conditions that could cause human safety issues for our personnel. All that could have been done in advance. Trying to meet design specs, where a simple soil test in advance and a little computer modeling, we could have designed whether or not that electrode system would hit 5 ohms in advance before it ever got even put out into the field. And it's just a confirmation. It's not like you can go down to Home Depot, right, and say, well, give me two 25 ohm ground rods, throw in a 15 ohm and put one of those 5 ohmers in there while you're at it. It doesn't work that way, right? A ground rod, a 10-foot ground rod in a given soil is going to equal a certain resistance, period. It's just science. It may not seem like it's science, but it really is. And if it's high, it won't be any higher or any lower. And if it is, you need to call out the Mythbusters and let's figure out what's happening, because something has violated the laws of physics, right? So we can design those things in advance, make sure there's proper test wells for maintenance in the future. Where do you want maintenance to occur? How much testing should occur? What do you want your local maintenance personnel to do versus what you want experts to come in later? Preparing these things in advance and having a properly designed system will lower your overall costs of maintenance down the road. And you can save a lot of money and increase your preventative maintenance safety systems for reduce electrocutions, make sure that people are properly safe. The list just goes on and on and on, particularly when we start getting into robotics, SCADA systems, computer server systems. You've got plasma cutters going in. You might need an isolation transformer so you can establish a brand new first service disconnect and a new neutral. All these things start becoming major problems if they're not properly designed from the very beginning. And to go back and alter systems that are already built always costs far more money than what we could have done up front. So what we like to do is we like to be involved from day one, right? Go out and get the soil testing done. Be involved with the design crew, making sure that all the systems are in place, reviewing the drawings and making sure that everything that needs to be documented is in there, and that the grounding systems, which are so vital to human safety and to the proper reliability of your equipment, are handled the way that they need to be, so that for the most cost-effective, efficient grounding systems that you can have, right? Anybody can run a production facility or their emergency services systems when the sun is shining and the birds are chirping, the kids are outside and playing. But particularly if you're in the emergency services group, the hospitals and the police departments, etc., when the storm is outside and the conditions are at their worst, is your communication system going to work? Will you be able to communicate with your fellow officers? Will your hospital be up and running, or will it, when the emergency power kicks on, are you all of a sudden going to have objectionable currents flying all over the place, damaging sophisticated equipment like MRI machines, and because someone had wired it up wrong? When lightning hits, is the power going to go out and breakers start tripping right in the middle of operations? All of these things need to be, if we handle them early on, we can make sure that when the conditions are at their worst, your systems are still up and running. And that's really what good grounding is all about. It's about reliability and human safety. But it needs to be looked at right at the very beginning in the blueprint phases, and we get a much better system, and it can save you money, lots of money. Recently, I can't get into the details, it was for a U.S. government job, but we saved them over $680,000 in cost because of being able to go back and get the design done properly versus what was originally planned in there. So you can really honestly see very significant cost savings and improved human safety and improved reliability if you get a good early involvement with a good grounding engineer who knows what they're doing and can help review your designs and make sure that all of those details in one of the biggest electrical systems that there is, your grounding system, is properly handled. It's a key infrastructure system. You're paying a lot of money for it, and it really needs to be looked at and analyzed properly. So that concludes today's episode. Thanks for listening. If you're on our podcast, I think you want to hit subscribe if you would be so kind, and leave a good rating for us and a comment. If you're watching us on YouTube, hit that like button, leave a nice comment, and of course, all the information is going to be down below. Lots of links, lots of info. Please visit our website, and always feel free to drop us a line or give us a call. We love to hear from you. Thanks a lot. Bye-bye.
Thanks so much for watching. If you found this episode helpful, please give us a quick like down below and subscribe to stay up to date on future educational videos we will be publishing. And feel free to post questions or comments below as well. We might even feature your questions in future videos. If you'd like to learn more about the amazing world of electrical engineering and grounding, be sure to check out our certified online courses at the links in the description below to kickstart your career. See you next time.